Hey everyone, how's each and every one of you are doing on this Thursday evening or Friday morning, wherever you're viewing this content. This is my first Precalculus video session in quite some time, since August, I believe. Yes. Yes, the reason why I've been busy with other students as well from other classes I'm tutoring or helping or assisting in some other ways. Most of them we do on Zoom and do through direct contact. But this is the first of many lessons on Precalculus. And so let's begin. Problems 26, 36, 37, 38, 39 is going to be involving trigonometric expressions. In this case, the first one, you have to simplify. Okay? It's a little bit treacherous from Algebra 2. From the other courses, if you're in high school or you're in college, you're taking calculus. This will give you an idea what you're going to be encountering with, okay? So let's begin. Problem number 26, simplify each trigonometric expression. Cosine, the numerator, cosine parentheses a plus b, parentheses close, plus cosine a minus b, parentheses on both sides, over the denominator, sine, parentheses, a and b, a minus b, parentheses close, sine minus sine, parentheses, a plus b, close parentheses. So this is the problem we're going to be encountering with. So let's go on. So we're going to have to expand these two, the numerator and the denominator. I'm going to write this on my notes, okay? Expand both. Okay, so you can see right there, expand both the numerator and the denominator, okay? All right, let's go on. Let's do the numerator. It's a little bit tricky, but forgive me I'm going to go a little slow for anyone, okay? So we're going to do the numerator first. We have cosine A, cosine B, minus sine, right? Minus sine A, sine B. Okay, we did the first two. Now we're going to do the same thing right here. Okay, yes, we're going to do the same thing. We're going to do a plus, because this is a plus sign in the middle. Plus cosine A, cosine B on the second part. Plus sine A and sine B. That's the numerator, okay? Can you see the whole thing? Cosine A, cosine B minus cosine A, sine B, plus cosine A, cosine B, plus sine A and sine B. Any questions so far on that part? Let me find the ruler. Oh, really? Give me a second, folks. I'm going to look at it. There it is. Yeah, I am. Well, I'm going to draw a line because sometimes my line's a little crooked. Forgive me. Give me a second. Okay, I'll put this down here. Let me put this. Let me face me. Give me a second, folks. Okay. I'm back. All right, now we're back. Now we're going to do the numerator. The denominator, actually. So we're going to do the denominator. So we have sine A, sine B, minus cosine A and sine B. Minus, if you lost in his notes, don't worry, because it'll be, I will send this to you, okay? All right. So, open parentheses, sine A, cosine B, plus cosine A, sine B. You close the parentheses. You actually are doing what you're doing right now. You see the whole thing? What I'm going to zoom in is this. You're doing the sum and difference formula. That is the big difference. You're actually doing the sum and difference formula. That's what you're doing right now, folks. So we got sine A, sine B minus cosine A, sine B minus, open parentheses, sine A, cosine B plus cosine A, and sine B, close parentheses. Now you expanded both sides. So any questions on this part? It gets a little bit easier, okay? All right. So we're going to do is, well, basically when you actually going to break it down is this. This is going to wind up happening. Since we have, on the numerator, we have two parts. So it'll be 2. And we have cosine A on both and cosine B, right? Okay? Over the same thing in this bottom part, but instead of being positive, it would be a negative 2 cosine A and sine B. Okay? It's a little bit tricky, but it's once you factor out, cancel out terms, you see why. So we have the numerator 2 cosine A, cosine B over negative 2 cosine A and sine B. Are we up to date on this part? We can look over the video, go over the steps one more time, previously from the previous step. You're okay. Give you a minute or two, to see if you need any steps. You are more than welcome to stop the video at any time. All right, we're good so far? Takes a little minute, it'll be a moment, but you can see why in a few minutes. All right, the next thing we need to do is cancel out common factors. What are common factors? I see cosine A, and 2, right? Cancel out factors, common factors. Okay. Then what's left over, we have cosine B over negative sine B. All right. When you see this, what identity we are using? Anyone take a guess? What identity we're using? Is it? Give me two choices. It actually give you an idea. It's something about division. What letter does it start with? A letter Q, right? What's the rest of the word? Quotient, right? Quotient identity. This is a quotient identity. This is what you're looking at. This is where you see a cosine on top, cosine whatever letter. and sign in the bottom of the denominator, this when you see this is one of the identities in your formula. So we have a quotient identity. So we have cosine over cosine b over negative sine b, which turn out to be what does it come up to? The answer would be a negative for sure. When you divide a positive over a negative, it would be a negative, right? Is it secant, cotangent, or those two? One of those two. Which one is it? Just look on the computer. Give you an idea. Give me a second, folks. Look here. Give me a second, okay? So we have here, this is the tangent, the quotient identities, right? We have tangent theta, sine over cosine, that's one. But this is what we're looking for. We have cosine over sine, that would be what? Cotangent. Cotangent B. That is our final answer. I'll write this down. When you look at the formula, right? This is the formula for this. This is an example. Cosine theta over sine theta, that's an example, equals cotangent theta. That's the formula. That is the formula for this. So we have it. We have cosine B over sine B equals negative cotangent B. This is the formula. So, any questions on number 12? Number 26. I'm looking at the time. 26. All right. If there are no more questions, let's move on to the next page. All right. Let's see. Forgive me on this because I'm trying to make sure everything is going smooth. All right. I'm going to use a different pen. I use a different pen. The other one's okay, but I have to use different kinds. That way you can see what I'm writing. Okay, folks? All right. Let's see this. The number 36. We have negative 2 plus sine squared y equals 3 cosine y plus cosine squared y. And you see the parentheses like a semicolon, and the brackets is the 0 and pi. It's going to be very important. I'm going to tell you why. So let's look. We have the problem read out. Let's do this. When you see this part, this entire problem, which identity did we use? It's not identity. Okay, I'll give you a clue. This is not identity. So in this part, we're going to use a theorem, an identity. But it involves something we did in algebra 1, from algebra 1 till now. It starts with the letter P. Can you take a guess what it is? The Pythagorean theorem, right? Identity. The Pythagorean identity. I'm going to write this down for you. Let me get the identity before I made a boo-boo, okay? Okay, let me go back. This is what it looks like. The Pythagorean theorem, the Pythagorean identity, right? So it's going to be very, very different, okay? This is the Pythagorean theorems. We have sine theta plus sine. Oh, here you go. This is one. Sine squared theta plus cosine squared theta minus 1. Secant squared theta minus tangent squared theta equals 1. Same thing with cosecant and cotangent. Okay, it's a little bit tricky, but I'm going to show you why. Okay, this is a Pythagorean theorem, okay? The identity. I was there. Made a mistake. Ugh. Get out of my head. So the Pythagorean identity. So we're going to do this. All right. Let's see. Okay. Got the message. All right. So we have this. This is using the Pythagorean identity. This is what we're going to wind up doing. I'm going to put it in the bottom. So we have negative 2 plus, open parentheses, 1 cosine square y equals 3 cosine y plus the remaining 2, the remaining part. So we have 1, negative 2 plus, open parentheses, 1 minus cosine square y, close parentheses, equals 3 cosine y plus 2 plus cosine square y. So that's the first step. Okay? This is involving the Pythagorean identity. So when you look back in your notes, you can see why I used this part. Any questions so far to this part, to this notion? All right. Now we can combine terms. Combine like terms. Okay? Now we have a negative 1 minus 2 cosine, oh, that's right, 2 cosine square y equals 3 cosine y. Because, look at the previous step. We got negative 2, like what it says before. Right? Yeah, that made sense. It does make sense. Because when you move this over, this is where the negative 2 is at. You see the cosine square y on the right side of the equation? You minus to that side, to the left side. That's how you get the negative 2. The negative 1 is minus 2 plus 1. That gives us negative 1 on the left side. And on the right side, we got 3 cosine y. So far, you're up to par at this point. It made a little confusion. Let me do this. Let me do it the easier way. No, yeah, you know what? Give me a second, folks. No, let me do it. Yeah, a little bit easier. Give me a second. I don't want to confuse someone who's looking at this video very carefully. Let me do this. This is how they got it. Okay? Forgive me. That's how they got it. I think that's how they get it. All right, now it looks better. It looks clean up just a bit. Let's do this again. So we have this. Yes, that's right. So negative 2. Okay. Let's do the left side. Let's push this over. So we got a negative. What's the opposite of add? Is subtract this number over to the left side. All right. And then this is what it looks like. And then we could do this. Negative 2 plus 1 to give us what number? Negative 1. Then what's a negative 1 and negative 1 equals a negative 2 cosine square y. Cancel this out. Bring down the 3 cosine y. That is combining like terms. That's what the combining like terms look like. Forgive me on the mismanagement, but forgive me. This is why I wrote combine like terms, because this will add up together. So far, so good. Can you see that? Perfect. Now we're going to rearrange just a bit. So we can rearrange. So this will go at the front. The sign will change. So it'll be a positive 2 cosine square y. Wait, hold on. This looks confusing, but it's not, okay? Alright, rearranging just a bit. Rearranging. You see the negative 1? That'd be it at the end. Y. Oh, that's okay. I'm going to put plus 1. Alright? And this will bring it over. We'll bring this over, rearrange it just a bit. We'll set this up to 0, actually. So we're going to set up to 0. This will go up first, so this will be a positive 2 cosine square y. And then you bring the 3 plus 3 cosine y. And then make room for this. Plus 1 equals 0. That's rearranging. Rearrange. So we have 2 cosine square y plus 3 cosine square y plus 1 equals 0. Now we have to factor out this part. Yes, we have to factor out. So this is going to be a fraction, to be honest with you. Factor out. This will be turned into a fraction. So when you're looking at this part, you see, yes, this is going to be all here. It's going to be a factor. So we have brand new in parentheses. No, it's going to be 2 separate ones. So we have 2 cosine y plus 1, parentheses close, and then do 2 separate factors. Cosine y plus 1 set up to 0. So we have 2 in the factor part, 2 cosine y plus 1, close parentheses, open parentheses, cosine y plus 1 equals 0. And then, any questions so far on this part? It's a little bit confusing, but forgive me, but the steps will come into fruition, okay? All right. Then we can figure out this. We're going to solve for cosine, right? Solve for, that ran out big time. Solve for cosine y, right? Right? We look for solve for cosine y. This will be Arrow is better. Cosine y equals negative 1/2, or cosine y equals negative 1. So, based on what it looks like, find the solutions in the given interval, and this is what it looks like here. And give me a second. The final answer, find the solutions to the final one, is this: y equals 2 pi over 3 equals pi. 2 pi squared over 3 and pi. That's our answer. Because due to this 1/2, let me see what 1/2 looks like. Give me a second. Make sure the answer is in radians. Okay, and this is the final answer. When you look at the cosine, and this will pop over here. The negative 1/2 is 2 pi over 3, and the negative 1 is just pi. So, any questions on number 36? It's a little bit confusing, but it's not when you look at the step very carefully. Okay. All right. So which steps you're missing, or make sure this is the Pythagorean identity. Make sure you use the theorem, the identity to the t. Then this part will come up. You have to subtract cosine square from the right to the left, and the right side will cancel the cosine square y. And then what's left over on the right side is a positive 3 cosine y. And once you do this part, we got a negative and a negative, negative 1 and negative 1 would be a negative 2 cosine square y. Then you do negative 2 plus 1 to give us negative 1. So that's combining like terms. Then rearrange it. Then we got 2 cosine square y plus 3 cosine square y plus 1, because this negative 2 cosine square y turns positive, and then the same thing with the negative 1, and everything else out to 0. Then you factor out the left side of the equation. It does make sense. So we have 2 cosine y plus 1, another set of parentheses, cosine y plus 1, and then to solve for cosine y, we have cosine y equals negative 1/2, or cosine y equals negative 1, and this what looks like the interval for that, the given solutions for the given interval, negative 2 pi over 3 and comma pi. So any questions on 36? I'm going to stop right here, and I'm going to do another one, okay? All right, be back in a second, folks.